that would be 1 upon root 3. This value will come here. Because dt upon root 3, it will be dt upon root 3. dt upon root 3 will come here, I think. The first part. Oh, sorry, this is that one. So in that way, under root 3 doesn't come in case of this x upon a. Okay, so that is the only value. Okay, so this is the final answer. Or we can just check it, that not a matter of discussion. Now, I'll just do the same type of question, because I think there is another question which is not that. Okay, last question, that is in 10 inverse, okay. And this one, I think 20th we have done, which is 21st. Let me take 22nd. This question, if there is any doubt, it can be further solved by taking step by step question. Okay, after substituting the hyperbola functions, that is, or if there is any minor mistake of negative positive, that may be there. Okay, but in this case, we can. This is the process I'm just talking about. That how we can do the questions. Either directly we can substitute. Let me take next question step by step. 22nd question here. 22nd question is sign of integration. This is secant x, okay, into log of secant x, alright, plus 10x, alright, into dx. This is what? Yeah, okay. Now we know that what is differentiation of log of secant x. No, integration of secant x. Integration of secant x is log of secant x plus 10x. Okay, so differentiation of that will be this value secant x. Let me write here log secant x equal to, let log of secant x plus 10x equal to t. No problem. Now differentiating with respect to t. Differentiating with respect to t. Differentiating it with respect to t, we get, it will be log of means 1 upon first it will secant x plus 10x into, it is further differentiated. Secant x is differentiated as a function of function method. Secant x into 10x plus 10x is differentiated as secant square x into dx upon dt. Okay, equal to 1. Therefore, now from these two we can take secant x common. It will be secant x common. In bracket we will have secant x from this and plus 10x from secant. This one divided by secant x plus 10x. Okay, so this is cancelled out into dx equal to dt. That means secant x into dx into dt. This can be written as, let me write first log. Let me change it. So it is log of first is secant x plus 10x, then secant x into 10 into dx. Now it can be substituted, which we have just assumed. Substitution will be for log of secant x, this is t into dt only. This is nothing but t square upon 2 plus constant of integration. Where t square is what? That value. It is nothing but log of 1.2 that we write here. Log of secant x plus 10x whole square plus constant of integration. Now this 2 cannot come before. If it was log of this angle upon angle it was, then this 2 could be taken. Now in this case it means log of secant x plus 10x into log of secant x plus 10x. It's a repeated repetition. So t is log secant x plus 10x. This is the answer here. This is final answer. No any other substitution here. Substitution this we have done. So this is the answer of this question. Question number 22nd. Let me take the other questions. question 21st was a repetition of two. I mean, there was two questions involved in it. So I'll take that in very, okay, in the last, let me clarify that further so that the answer can be checked whether it's was true or not true, because sometimes minus plus may be there, but or numerical value may be different. Now 23rd question, let me talk about it. Question number 23rd. It is 1 minus x upon twice x plus 3 into dx. Okay, so this kind of questions, if there is x in the numerator, we have to make such kind of substitution, I mean multiply or divide, so that the denominator can be obtained in the numerator. Then we divide the numerator by denominator and it will be 1 in that case. So if I multiply this by 2 and divide by 2, so no change, it will be, okay, if I write here minus 2, okay, I have to divide minus 1 on 2. Okay, so it will be twice x, let me write plus 3. It means if I multiply this whole, it will be minus x, no problem. Second part will be minus 3 upon 2. So minus 3 upon 2. This I have okay, subtracted one more question. So let me add 3 by 2 and plus 1 was there. It will be 5 by 2. The addition will be plus 5 by 2. Because we know that 5 by 2 and minus sign is 3 by 2 will be what? 1. 2 upon 2, that will be 1. So same thing will be obtained. So what we have done, we have done this kind of substitution, this kind of multiplication and addition here, so that this question numerator is changed like this, and this minus 1 upon 2 we have taken out upon sorry, this 5 by 2 is just separated, because minus 3 by 2 plus, let me take this minus 5 plus 5 by 2 out here. This is 100 upon 2x plus 3 plus it will be 5 by 2 kind of integration of 1 upon twice x plus 3. In these two parts we have divided this whole. Now it's okay. The reason is because from first one we will get minus 3 by 2. The second one we will get 5 by 2 only. 5 by 2 minus 3 by 2, that means plus 1, which is there. The whole thing, the numerator has been changed like this. This we get only 1. Sorry, this is dx also. Okay, this is minus 1 upon 2 kind of integration. Only dx because this is 1. Same thing upon same thing. 1. This is plus 5 by 2. And this is nothing but 1 upon, okay, twice x plus 3. Now we know that this is what integration. This is ax plus b type function, and this is log of ax plus b divided by a coefficient. So this is simple value, minus 1 upon 2, this is x only, integration of 1 here, plus this is 5 by 2 into log of twice x plus 3 upon 2. Okay, the reason is, if I do this by substitution, you can do, but this answer is this one plus constant of integration. This is minus 1 upon 2 x, that is 5 by 4 log of twice x plus 3. So no change. Whether it is true or not true, if I do this proper substitution, in the second part, first part is okay, this is minus 1 upon 2x, this is right. The second part, the denominator, if I take like twice x plus 3, let equal to t. Therefore 2 into dx equal to dt, or dx equal to dt upon 2. This is after differentiation with respect to t. Okay, so what we have done, this value, let me take second part, this is 5 by 2 second part plus 5 by 2 sin of reduction 1 upon t now, dt upon 2. 2 will come here, this is 5 by 4. Sorry, this is 5 by 4. Okay, this is log of t, because 1 upon t means log of t integration. 1 upon 2 we have taken out. will be only 1 upon t dt. Let me take one step further. This is 1 upon t into dt. Now to integrate it as 5 by 4 log of t plus constant of integration. So t means this one twice x plus 3. The same thing we have obtained, log of twice x plus 3. As we have already clarified that whenever there is this kind of single, linear factor or linear equation, this is linear equation, okay, binomial equation, or binomial and linear equation. This is twice x plus 3. So we do this as log of something. It may be 1 only, and it is log of something, and whatever coefficient is that we divide. So directly we can do, or we can substitute like this. The second part is this, and first is this. Final answer is same thing. 1.2, this is repeated, plus the same thing here, 5.4 log of. So without any substitution we can do this. There's no any mistake here. You know that this is log of this value and divided by coefficient of x by 2. This is the answer. Same answer is also like that. Okay, so this is question number 23rd. In this way we can do the questions by substitution. Okay, now let me take 24th question. Question number 24th, what does it say? Question number 24th. Now it says, 24th question, x upon under root, okay, a square minus x4 into dx. Okay, now in this case let us take, let me write it as sign of integration, x upon under root a square minus x square whole square. So let x square equal to, let x square equal to t. Therefore differentiating with respect to t, twice x into dx equal to dt, or x into dx equal to dt upon 2. This is after differentiating. This are only okay, express number of times differentiating with respect to t. So it will be twice x into dx upon dt equal to 1. Take dt to that side, it will be x dx here. Take 2 to also that side, so just dt upon 2. It is dt upon 1. X dx equal to dt upon 2. This can be substituted here. X dx, sorry, this is dx here. Remember that we have dt upon 2, that means 1 upon 2 we have taken out. Sign of integration, this is a square minus, okay, and x a could also be repeated. I'm sorry, this is a, we have to take here. A into x square we have to substitute here. It will be a here. Okay, so a upon a also. Dt upon 2a. It is dt upon 2 out of the brackets. It is dt upon 2a here. Let me remove a square also. So it will be a square into t square. Now, because ax square we have taken in place of ax square equal to t, that means t square it is. It is t square only. You know what I'm doing. Then let me take x square equal to 80. I'm sorry. This is x square equal to 80. Then a will come here. It will be 80 a square t square. I'm sorry. Let me do it again. So it is differentiation twice x dx equal to a into dt. It will be x dx equal to a dt upon 2. Okay, so this is x dx equal to a dt. A will be in the numerator. I'm sorry. This is a into dt upon 2. Now it's okay. Because in place of x square we have substituted at. Now this is at whole square. That means a square t square. Now we can take a again common out of this square root. It will be equal to a, which will be cancelled out now. Because out of this will come out as a. This a is cancelled out. The sign of integration dt upon under root, it is 1 minus t square. Now this is directly tan inverse t. But we know that's tan inverse t, 1 minus t square. We substitute t equal to sin theta, sin inverse t. So this is sin inverse t. A cancelled out. It will be 1.2 into sine inverse t only. So t is what? X square upon A. That is very easy. We can substitute it further. Let me take constant 1.2. It is nothing but sine inverse. T means here t x. This implies that t equal to x square upon A. It is x square upon A plus constant of integration. This is answer here. So question. Okay, we have taken the answer finally in x. Terms of x here. It is 1.2 sine inverse x square upon A. 1 minus t square under root. We know that this is sine inverse t, not sine hyperbolic or nothing. This is 1 minus t square. Because in case of sine hyperbolic, it must be plus sine 1 plus t square. Then it will be sine hyperbolic inverse x square upon A. Okay, but in this case, it is simple sine inverse x square upon not hyperbolic function. This is the answer. So it was 1 minus t square. Okay, so this question is not of hyperbolic but simple trigonometric function. Now let me take next question. It was 23rd we have done. Sorry, 24th we have done because it was x square 80. Now 25th question, let us talk about. Question number 25th here. 25th, let us talk about. Okay. Question number 25th is sine of integration is secant x into cosecant x, okay, into cosecant x upon log of 10x, okay, the log of 10x into dx. If I take log of 10x equal to t, again substitution that log of 10x equal to t, differentiating it with respect to t, differentiating with respect to t, or on differentiation with respect to t, we get this is proper sentence. It will be 1 on 10x first, okay, into second, or 10x is again differentiated into secant square x into dx upon dt equal to 1. That means secant square x upon 10x. Let me further resolve it is equal to dt. Now if it is, or this implies that second, 1 second, let me separate. Okay, so and 1 on secant x is 1 on cos x. Okay, whereas 10x is sin x upon cos x. This cos x and this cos x cancel out because this cos x will come. This cos x will come in the numerator. Numerator to cos x upon cos x cancel out. 1 on sin x is secant x, sorry, secant x. It is nothing but secant x into secant x into dx equal to dt. The same thing we have obtained here. Okay, in the numerator, so it is nothing but dt upon t. Simple. This is t we have assumed in this one. Let us take this. Okay, let this on differential with respect to t. So we have got secant x for secant x dx equal to dt in the numerator. The same thing. It's nothing but log of t plus constant of integration. Now log of t is what we have taken as log of 10x. Okay. T is nothing but log of 10x. Log of 10x. This value is okay plus constant of integration. This is this kind of question. You can write the same thing. If I write this big square bracket and this is smaller bracket, okay. So this is the final answer. Double log of 10x, log of 10x. Okay, sorry. Now next question. This is 25th. Is the answer here. So question number 25th we have done. Now let us take 26th question number 26th. Question number 26th. Question number 26th was, okay, this is question number 26, sine of integration. Here sin x cos x into cos x divided by plus sine 4x into dx. Okay, now in this case we can write it as sine square x whole square, that we write it as sine x into cos x upon 1 plus, this is nothing but sine square x whole square sine 4 power means. In this way we can write it as. Okay, now let us assume that sine square x equal to t. Now differentiating it with respect to t, differentiating it with respect to t, we get it will be twice sine x. First differentiation, sine x is not x, so we have to differentiate again, it will be cos x. Now x is dx upon dt, x is further differentiated because we are differentiating with respect to t, it is one only, which is sine x into cos x into dx equal to dt upon 2. The numerator value is this. Now let us substitute this. This is 1.2 we have taken out of integration sign, and this is dt divided by 1 plus t square. What is this? This is tan inverse t. The tan inverse t value, this is nothing but 1.2 tan inverse t. Directly we can substitute as constant of integration. Now this is 1.2. If it is without square root 1 plus t square positive value, then it is tan inverse t, not hyperbolic tan inverse t. Sorry, this is tan inverse simple t, simple trigonometric function. This is tan inverse. What is t here? T be assumed as sine square x, sine square x plus constant of integration. This is the final answer. Question number 26 here we have done. Now let us talk about question number 27th. 21st I'll take next. Also I'll do it in a proper manner, so that I did directly, so students may not get it or may get it. I don't know. Let me do that simply in simple terms. 27th, let me first do the last question. Then 21st I'll do again, so that step by step that question can be understood. Okay. 27th question, let me talk about. This is sine of integration ex divided by sine of integration, this is 1 plus e raised to power twice x into dx. Alright. Now in the denominator we have under root, so 1 plus ex whole square. Ex whole square means e raised to power twice x, same thing, into dx. Let us take ex equal to t. In the this one, ex equal to t, differentiating it with respect to t, differentiating it with respect to t, we get ex into dx upon dt is equal to 1. Ex into dx equal to dt. Okay, so this, in place of this in the numerator we can put dt. This is nothing but dt upon, or 1 upon into dt. Yeah, this is under root 1 plus t square. Now this is sine hyperbolic inverse t, nothing else. This is sine hyperbolic inverse t plus constant of integration. Why? Because this is under root 1 plus t square. Simple. It is 1 plus t square, or x square plus 1, x square plus a square, whatever. Then if it is 1, then it is sine hyperbolic inverse only t. Only if it is x square, then it is x. If it is a square also, a square plus x square, then it will be sine hyperbolic inverse x upon a, that means t upon a would be the answer only. Now let me substitute the value of t. But we assume t e raised power x. E raised power x we assume as t plus constant of integration. Now this hyperbolic inverse, you know that what is this in terms of log, or this is, or either this form is the answer, or you can write here log of e raised power x is plus under root, this is 1 plus here e square 2 or e 2x. This is the same thing. This is x into ex, I think. Here is for x under root. This is x into x is here ex. Ex plus ex under root 1 plus e twice x square. That was under the experiment value. This we could do. Okay, so that was here. Ex plus ex under root 1 plus, I think ex is also there. This is ex upon here 1 is there, x square upon 1, or ex upon 1 only. You know, if it was a, then it was a here. It is simply ex upon a. Okay, so that value is there. Ex is separated plus x into under root x square 1 plus x square. That was the value here. I think is the answer. This is a final answer here. Or this is answer. This is the best answer here. No further explaining in log of this. We know that from the beginning that it was log of this function also. We converted this into log also. So it was log of this value. Sin hyperbolic inverse was expressed in terms of log also. This is plus sin c constant. This is 27th, the last question. Let me talk about 21st question, which I just told you that I can repeat it again in the simple terms. Because there also I repeated the values. Okay, or I put the value directly without following that. Take 21st question again. Question 20 is x square plus 1 divided by under root x square plus 3 into dx. Here we just write as x square under root x square plus 3 or minus 2. We change divided by x square plus 3 into the square root into dx. It was divided into two parts, x square plus 3 divided by under root x square plus 3 into dx. Minus twice sin of integration 1 upon under root x square plus 3 into dx. This in two parts it was divided. So this is simply under root x square plus 3 only, because this whole can be taken in the numerator. Numerator is having 1 over, 1 minus half means half over. It is in the square root minus 2. Now this is the same thing, under root x square plus 3. Now 3 can be written as under root 3 whole square. This is also under root 3 whole square. Okay, it's the same thing. This is in two parts. Decided that without any substitution, if I substitute here x equal to sin hyperbolic theta in this case also, let me substitute in that way. So in both ways we can substitute. Let x equal to under root 3 into sin hyperbolic theta. The theta here, differentiating it with respect to theta. With respect to theta in both doing simultaneously, that it can be achieved easily. Okay, so this is theta, therefore let me write from this also with respect to theta, and this implies, I'll write that later in the last. So first is dx therefore equal to dx upon d theta. Let me write equal to under root 3 into sin means cos hyperbolic theta. That will be cos hyperbolic theta, or dx equal to under root 3 into cos hyperbolic theta into theta. This is in place of dx. Now let me write here, this is under root 3 which we have taken out. Under root it will be x square means 3 into cos hyperbolic square theta in place of x for is sin hyperbolic. The first one is, in this case, this is sin hyperbolic square. This is sin hyperbolic square theta plus 3 in the square root, the same value, into dx is under root 3. This is into, the square root here, and this is dx. Dx means under root 3 into cos hyperbolic theta into d theta. This is first part. Second part, let me write here also. Dx it is. Now dx is the same value under root 3 into cos hyperbolic theta into d theta divided by inside it will be 3 sine hyperbolic square theta plus 3. Okay, d theta we have written. These are two parts here. Let me do them simultaneously. Now under root 3 from this one will come out. That means 3. Under root 3 into under root 3, that means 3. It will be 3 then. Under root, it will be 1 plus sine hyperbolic square theta into this is, okay, this under root 3 is also there. 3 under root 3 it will be, I'm sorry, 1 under root 3 is this, under root 3 from this also come out, and this under root 3 is, sorry, this under root 3 I think I need to down here. And where this under root 3 has gone, only 3 will be there, I'm sorry. For this under root 3 I have repeated. For this under root 3 I have written down here, and this is only cos hyperbolic theta. So this is 3 under root 3 into under root 3 from this side with 3 only. Okay, so no problem. This is cos hyperbolic theta into d theta minus sine, here it is 2 from inside, from this one you will have under root 3, the same thing will come out. This cos hyperbolic theta into d theta upon under root 3 we will take out of this, because this is under root 3 whole square root, and this cancel out, under root 3 will come out, and inside it will be 1 plus sine square, sine hyperbolic square theta, that means cos hyperbolic square theta. The square root is cancelled out, it will be cos hyperbolic theta only. These two are cancelled out, only d theta is left over. The final value is 3. From this it will be cos hyperbolic theta will come out, cos hyperbolic square theta, then 3 sine of 20, it is cos hyperbolic square theta into d theta. Minus this is nothing but 2 into d theta. Now let me integrate that. So integration, substitution we have, okay, that is there. Now let me write here this also. So this will be 3. Now it can be converted further. Cos hyperbolic square theta, you know that cos 2 cos hyperbolic square theta equal to cos hyperbolic 2 theta plus 1 upon 2. Therefore cos hyperbolic square theta